Good afternoon, everyone. We are still gathering. I'm just going to hold about one moment as we let a few more people get into the webinar, and then we'll get started. But thank you all for joining. This is Bobby Harris with the Utility Broadband Alliance, and we're just going to give one more little minute for a few people who are logging in now to join the webinar. All right, it looks like the additional attendees are beginning to get logged in, so I appreciate everyone's patience. Again, this is Bobby Harris with the Utility Broadband Alliance, and I'd like to welcome you to our webinar today. We're focusing on technology considerations for utility private broadband networks. All of the attendees, you're all in listen only mode. You're muted for now. You can use the questions tab on your dashboard to submit a question to the panel, but we're going to hold all questions to the very end, and then we'll try to get to as many questions as we can during the presentation. If we don't get to your question, we will follow up via email with you if you'd like us to do that. So you should all be able to see my screen. And let me first start with the Utility Broadband Alliance guidelines. You can read there on your screen. These are confidentiality disclosures and, of course, antitrust disclosures that we just want to make sure everyone's aware of. We do follow these rules when we have all of our meetings, and we want to be sure that you're aware of that as well. So first up, let me just quickly introduce you to our speakers. I'll give you more details on each one as we go along. First, we have Alan McIntyre from Southern Linc, Mark Poulin from Anterix, Warren Westrup from Sierra Wireless, and Kreg Christoff from Motorola Solutions. All of our speakers today are founding members of the Utility Broadband Alliance, and they all serve in leadership positions in our Alliance's working groups. So they've been quite involved over this first year of UBBA. Here's our agenda for our webinar today. As you can see, we're going to speak about some different technology considerations, and all of the speakers will give their perspectives on these key assets of utility broadband networks. First, just a little bit about the Utility Broadband Alliance, who brought you this webinar today. We're now right at a year old. We launched softly at Distributech last year, and I'll share at the end of the webinar a bit about our event coming up next week at Distributech again. The Utility Broadband Alliance is a collaboration, really, of utilities and our technology partners that are dedicated to the advancement and development of private broadband networks for critical infrastructure. At the moment, we have grown to 28 members. You can see them all listed on your screen here, 8 of which are utilities. They all participate in our 4 working groups, and I'm happy to give you more information about that. If you're not a current member of the Alliance, certainly you can reach out to me directly. You'll get my email at the end, or you can go to ubba.com and click the Contact Us button, and I'll surely reach out to you then. So without further ado, let's get straight on with our webinar. Our first speaker today is going to be Alan McIntyre from Southern Linc. Alan is an engineering director and began his career with Southern Company and Southern Linc back in 1995. He received his Bachelor of Electrical Engineering and Master of Business Administration from Auburn University, and he is currently serves on Auburn University's Wireless Advisory Board. Alan, I'm going to let you take it away, sir.
Okay, thank you, Bobby. Appreciate that. When we talk about a webinar that, the title's technology considerations, I mean, one thing that really stands out is spectrum. I think it's kind of the fuel, from a utility view of, how you kind of get off the ground. And so, out of the, Bobby mentioned there are different working groups as part of UBBA, and I'm on the technology working group. As an output of that group, we developed a kind of a spectrum considerations or alternatives spreadsheet that utilities hopefully could use to investigate different options for spectrum that may fit their needs, so that they could pursue private broadband. And really, everything we've done is really an LTE view. And so, kind of looking through it with that lens, kind of walk you through what we've put together, and and hopefully it'll help somebody. We really broke it into two different options: low band and high band, or low band and mid band. And low band is sub 1 gigahertz spectrum. And so, out of what you see here, the first slide are the low band options. And so, we've got 4 options listed. One is 406 to 420, and we listed different spectrum ranges. We kind of get into some of the other pieces, kind of flowing over to the right-hand columns. But 406 to 420, and if you kind of go over to low band, the next column is propagation characteristics, and that's the free space path loss in dB at 15 kilometers. So we wanted to have some kind of metric, because one of the first question is, how does this band compare coverage-wise to another band? And so this was how we kind of got at that question. And so we used 406 to 420 as the baseline. And so the next column is the free space path loss delta. And so as we go through, you see that delta grow, and that's the difference in free space path loss between this 406, 420 band and potentially other options. So that's kind of the frame of reference there. Any interference mitigation concerns, typically that was if there's adjacent licensees or adjacent issues that just to be aware of. Then as we get into, and like I said, it's an LT view, so LT channel bandwidth supported, LT operating band, whether it's frequency division duplexed or time division duplexed. And that really drives the spectrum, whether it's really, you have an uplink and downlink, or it's one band and you do it by time, uplink and downlink. MIMO support, so that really drives, and that's really from an equipment standpoint, more so, and that can drive, capacity and data rates. The timing, if there is a timing aspect when the spectrum would be available, or if it is today. LT readiness, and so that is somewhat of a subjective metric as far as how developed is the ecosystem for that particular spectrum range today. And so I'll use a couple as an example here in a minute. Public, shared, private spectrum. So would you have to share the spectrum with somebody else? Is it your license for it? It's private spectrum or public. Think of Wi-Fi as a public band, and that'll be an option that we'll kind of talk about a little bit. And then considerations are some notes, more so than anything. And I probably need to give a shout out to Lauren Baskar, who was with Burns and Mac. She actually helped put together a legend that kind of summarizes all those column headings that I just went through. But going now down the list, 406 to 420 we've talked about. It's a band that UTC is advocating for with the FCC now. It would be sharing with the federal government. Federal government's in that spectrum range now. And so you see a lot of TBDs because there's been no work really through the 3GPP standards process to define that band. And so don't really know what the bandwidth would be or the operating band. And so a lot of things are still to be worked out, assuming that the FCC and NTIA would allow other uses in that spectrum range. And so one to pay attention to and kind of keep on the radar, but it is not available today at all. The next one is the 600 megahertz band. That was recently auctioned, probably a couple of years ago, I guess, maybe 3 years now. It's a band that is in the 3GPP standards, band 71, has different channel bandwidth options in that standard, the smallest being a 5 megahertz channel. It's an FDD band. The timing's interesting because there's clearing. There's some instances where TV stations are still in that spectrum. Some parts of the country and the TV channels have to be cleared to use it. But and we said low LTE readiness. That's going to change pretty rapidly. T-Mobile was a big winner of a lot of the spectrum at the auction, and will be deploying that band pretty heavily, especially for their 5G build out. So I think the readiness will rapidly change as that spectrum's built out, and you see band 71 in a lot of chipsets and in devices. And that's kind of happening now. There are some speculators that won auction or won spectrum at the auction, and so the spectrum availability would really be on a kind of a private sale basis with one of the speculators. The next one isn't really an LTE band per se. We listed it. It's an upper 700 megahertz band. It's the A block. It was a 1 megahertz block that was auctioned as a guard band when the 700 megahertz auctions occurred. The reason it's listed is there's some license holders that are offering it for narrowband IoT. So it'd be a standalone narrowband IoT. You need 200 kilohertz for one narrowband IoT channel. And so it is out there. It has not gone through a 3GPP process, so it's really proprietary type equipment that you'd be buying and using, but it is available, and so we wanted to certainly list it as an option. The next one is 900 megahertz spectrum, Anterix. Most everybody hopefully knows Anterix is going through a FCC proceeding now, and hopefully the report and order will come out very, very soon and establish that as an option. It would be a 3 megahertz block, at least initially. And so globally, that is band 8. And so, and as you can tell from the number, it's a low number, so it's been around a long time. And, globally, there's a lot of equipment. So the ecosystem is readily available and exists. And so, certainly a good option for low band spectrum. Bobby, could we go to the next slide? Thank you. These are the mid-band options, so greater than 1 gigahertz bands and really less than 6 gigahertz. So it's in the 1 to 6 gigahertz ranges. The first one, similar to the 600 megahertz option, we've got 1700 and 2100 that's paired. It's really extended AWS. There was an AWS 3 auction a few years ago. Again, there's some speculative companies that won spectrum at that auction. The band exists today, 66. Some of the large nationwide carriers are deploying that spectrum in 66, and so there is an ecosystem around it. And certainly all the major equipment players have equipment that works in that band. So certainly an option, but it would be more of a private sale of spectrum acquisition. Next one is it's the AT&T offering with the 2.3 gigahertz band, and so it's a little unique in the sense there isn't a 3GPP band built around it. I think it's some proprietary equipment that they use for that. It's a 3 megahertz channel. It does have some restrictions because you have Sirius XM satellite radio in between two blocks of spectrum there. So I think it's fixed operation only, according to our understanding. So, but it is an option. The next one is 2.5 gigahertz. Commonly, this is known as the Sprint spectrum band. They have a large holding across the country in this band, so the ecosystem is high. The FCC is going to auction. There were two types of licenses in that band, one of them being educational broadband service spectrum, and so the FCC is going to auction off the white space. Date is not nailed down, but tentatively supposed to happen sometime this year. With this band, we start into TDD spectrum. So you have, you don't have paired spectrum anymore. You have one block, and you do both uplink and downlink in that block. So certainly, from a ecosystem standpoint, that band is certainly in use across the country. Getting to the next one, 3450 to 3550. That one's it's kind of on the radar band, mainly because I'll talk about the next one. It's adjacent to it, but no real plans right now for anyone to be in that band. The federal government is the user right now, so there's a push to open it up. So something to monitor more than anything else. The one of maybe more interest would be 3550 to 3700. This is commonly known as the CBRS band, the Citizens Broadband Radio Service. There's really kind of two types of spectrum in this band. There's GAA, General Authorized Access, and any utility could really have access to that spectrum by tying into what's called a SAS, a Spectrum Access System. There's several SAS providers: Federated Wireless, Google, CommScope, and so you basically could use that spectrum by accessing the SAS, and you pay just kind of on a think of it on a per site basis. The other, I think there's kind of low priority on the GAA. That spectrum's also, you're sharing with the federal government. The aircraft carriers use that spectrum to land planes, and so if there's a aircraft carrier off the coast, it could restrict how much of that spectrum's available. So GAA could be at risk in those cases. So if you wanted more certainty from a licensing standpoint, there's the PAL license auctions, the primary access license, and I think right now the FCC set a date of June 25th of this year for that auction, and so that would give you more certainty. The auctions will be on a county basis. There are the whole band obviously is 150 megahertz, so there'd be 15 10 megahertz blocks. Of those 15, there are 7 that'll be auctioned as PAL licenses. The other 8 would always be GAA, and whatever doesn't get auctioned as PALs would become GAA spectrum blocks as well. So certainly a band that could be of interest to utilities for different use cases. The 3700 to 4200, 3.7 to 4.2 is known as the C band. It's a satellite band now. There is a lot of momentum to kind of open up that band for commercial radio purposes. Really, I think the larger carriers want it for 5G deployments, but looks like the FCC will auction at least a portion of that band. It's obviously pretty large, so somewhere around 280 megahertz may be auctioned, and they're trying to do that before the end of the year as well. So something else to pay attention to. It sounds like there'll be 20 megahertz blocks that they'll auction, so large chunks of spectrum there. The next one, the 4940 to 4990, is another band similar to 406 to 420 that UTC has been advocating with the FCC to share with public safety. Again, not much to report right now. It's a lot of TBDs there. Just something to monitor and see if it ever gets opened up, and advocate if it's something of interest. And the last one, really, this is a pretty specific use case one, but it's a public. This is really, think of it as the Wi-Fi spectrum band, but using it for LTE, and it's called license assisted access, and it'd really be more of a microcell option. But you can deploy multiple 20 megahertz wide channels in that band. So a lot of spectrum to be used in an LTE network, but the power certainly is limited, and the propagation would be smaller. So might have its uses, but nothing for a large geographic build out. So that's what we've come up with so far. Hopefully this information is useful and utilities can use it as they work through their technology considerations. Bobby, that's it for me.
Thank you very much, Alan. I appreciate you setting the stage for us. Then that's the kind of information that our utilities and our members of UBBA have access to. That's the kind of work that we've been doing day in and day out through these working groups. Next up for us, Mark Poulin from Anterix is going to jump in and talk about network architecture considerations. Mark is the director of IT network engineering and operations at Anterix, and he spent over 30 years creating and developing these technology solutions for wireless communication industry. He's currently on the private broadband solutions for critical infrastructure industry and is dedicated to broadband solutions around public safety and government agencies and critical infrastructure. So I want to not talk any longer and turn it straight over to you, Mark.
Thanks, Bobby. So what I'm going to talk about today are a handful of architecture options for deploying an LTE system for in a private type deployment for utilities. In our technology working group in UBBA, we looked at many options, and what I just did here is grab a handful of them. So we certainly covered a much larger set of these in our working group. And as Alan mentioned, our focus in the technology working group is and was on over last year was on LTE because of the global acceptance of LTE. So we feel that it's reasonable to focus on that as the broadband solution. So on this slide here, what I've got is what I'm calling your base private LTE architecture. And the key assumption here is this is a complete private LTE system, wholly owned and operated by a utility. So it's a standalone deployment, if you will. And I'm going to talk through really quickly here some of the building blocks of it, because as I move forward, these building blocks are going to move around a little bit. So on the left side of the picture, you've got the devices that are operating on the LTE network. So you've got grid devices, gateways, which tend to be fixed. You've got smartphone type devices, which tend to be mobile. And then moving over to the right, you've got the radio network or radio access network, RAN, and LTE terminology. And basically that's all your cell sites. And then you go through a backhaul network in the middle over to an LTE core. EPC is the term used in LTE for that. And you'll notice up at the top of the backhaul network, we've got edge LTE core to account for the fact that the architecture allows the deployment of some of the core elements at the edge of the network for various applications that benefit from the data staying local. Then continuing to move over to the right, we move over through the core's IP backbone network over to the application side, where you'll have some grid applications, perhaps push-to-talk for the smartphones, and then network operations, the NOC. So these are the basic, these are the elements of LTE architecture. And again, in this picture, this is we're looking at a standalone deployment, utility owned and operated. Bobby, you can move to the next slide. So the first alternative to that I'd like to talk about is, we'll start with the question, what if there's two utilities, okay? And those two utilities have, and I'll use an example, say those two utilities have some part of their system coverage areas that overlap. So let's think of it as overlapping service areas between utility A and utility B. There's a technique in LTE called RAN sharing, or shared RAN as I've described it up there, that enables two, and I'm going to call them two standalone private systems to share the pieces of the radio access network. And when I say pieces, I mean a subset of sites that are deployed. So imagine you've got utility A and utility B, each with their own standalone private deployments, and then within those standalone private deployments, there happen to be a subset of sites that overlap. They overlap with each other, and this is a technique. This is what RAN sharing allows them to do, is share those sites. So let me talk through the slide in a little more detail. So I've got devices on utility A and utility B, and the SIM cards in those devices go with each utility. The SIM profile, some are for utility A, some are for utility B. In this picture, I've only drawn the sites that are shared. So in the middle there, we've got the LTE radio network, the sites, and those are being shared. If you look across to the right, they're being shared by the complete core and applications owned by utility A and owned by utility B. So what you effectively have in this type of an architecture is two utilities owning and operating their own private systems, but there's a set of sites where they're actually sharing the access to those sites, so that devices from both utility A and utility B get access to their systems, their corresponding utility A and utility B systems, through the same cell sites. Next slide, Bobby. Okay, now another take on that in terms of sharing is we just shared the RAN. Now we can look at sharing the core. So again, here we have utility A on top, utility B on the bottom. And the desire here is that this is more of a efficiency of deployment or efficiency of operations scenario where these two utilities desire to deploy their own networks, yet they'd like to share that LTE core, perhaps for operational cost savings, things like that, or perhaps they've distributed much of their core functionality to the edge because of the types of edge grid applications they're using. So it's more efficient to share the LTE core. So again, though, as you look at the elements here, other than that shared LTE core, each utility A has all the other blocks that we've described in the previous slides, from devices, RAN, radio network, backhaul, and then applications. Next slide. Okay, now I'm going to jump to a different look at sharing, and I'm going to call it sharing from a device profile. So now we're going to look at architectures where there's a desire to have devices that can operate on more than one network. So as we look at this slide, we've got the devices on the left, and each device that we're going to be talking about is a device that has a dual SIM profile, which means the device has the ability to support operation on two networks. And the example here would be one of the networks would be the utility network, and the other would be a public carrier, such as Verizon or AT&T or Sprint or T-Mobile or a regional carrier. So with the device that has that capability to operate, to utilize two SIMs, it can operate on a private network, which is what's drawn along the top. That's the same private network diagram that we drew in the first slide, a complete standalone private network. And then the device can also operate on the cellular carrier down on the bottom, the MNO eNode B and the MNO network. And this can be desirable because you might want an approach from the device perspective where the private system might not have the coverage that is completely necessary for 100% coverage, and you might utilize the public carrier to extend the coverage to where it's needed. And again, regardless of which system the device is operating on, it's getting access to the same set of utility applications over on the right. The grid applications, the push-to-talk, et cetera. So this is to allow for device multi-system operation. And one way to look at this could be a temporary mode, right? With a deployment like this, you could the utility that's deploying the private system in an arrangement like this could deploy its coverage over time, and the devices could be set up to prefer the private system, but then secondarily be on the public network. And as the private systems deploy, the devices would move off of the public network, which is already deployed, to the private network as it's deployed. So that's a scenario that this works for. All right, next slide. And then the next slide, shared RAN roaming is a different approach to accomplish the same thing on the previous slide. So we've got devices on the left, but these devices this time are devices with only a single SIM profile. So these devices are set up to operate via their SIM on the private network, on the utility's private network. Only in this scenario, what we've drawn is the utility is only deploying effectively a core and applications. So what you see as you move over to the right, you see the LTE core, the backbone IP network, and the applications all deployed, owned, and operated by the utility. But the utility is utilizing the public carrier, the MNO, basically for its RAN. And in this scenario, since the devices have the utility profile in the SIM, the devices are effectively roaming. They're acting as roamers onto this public carrier network. But while roaming, they're getting access to all of the applications that are being developed by the utility. So this is a different approach to providing operation on a public carrier, if you will. On a public carrier, but being part of a private utility system. Again, another way to look at this is this could be a transitive state also as you deploy, as a utility, as you deploy your RAN. You could deploy RAN, and the devices which are roaming onto the MNO could then move over to the private RAN when that private RAN is deployed. So this is another effective way for that, call it transition state type of operation. So again, that's the last of my slides. Again, this was a subset of the many architectures that we looked at in the working group, and there's certainly that's all documented if anybody is interested in getting access to the other options. But thanks.
Great. Thank you so much, Mark. So we've had some great information already, spectrum options, now network architecture options. And now I'd like to have Warren Westrup from Sierra Wireless come on and talk with us about those in-device considerations. Warren has more than 25 years of experience in electric and gas utilities, as well as wireless communications infrastructure. And he's currently the Director of Business Development at Sierra Wireless. He's worked, of course, across all of our utilities and our working groups to help build out the discussions. He has a Bachelor of Science in Electrical Engineering from University of Texas, Austin, and his MBA from Our Lady of the Lake University in San Antonio. Warren, without further ado, let's get to you.
Awesome. Thank you very much, Bobby. So the first thing I wanted to touch on, and Alan did a really good job talking about the spectrum issue for sure. So, the difficulty in getting spectrum. So, one of the things that I want to touch on is low power wide area, modules and gateways. So especially in the LTE world, you'll hear the term, narrowband IoT, CAT-M. The issue really boils down to the fact that, like Alan said, the private spectrum is limited. So, there's not huge channels like the telecom carriers, like the Verizon and AT&Ts of the world have. So low power wide area is really important when you think about building out a private LTE network. For a couple of reasons is, narrowband IoT, CAT-M, especially narrowband IoT, we're talking about much smaller channels to be able to send the data. So 200 kilohertz channels, which is perfect for a lot of the fixed applications, SCADA applications, fault indicators, that sort of thing that a utility would be interested in implementing. And so it allows them to add more connections over that spectrum. The other thing that's important too is when you think about it, the maximum coupling loss when you're dealing with low power wide area is about 20 dB greater than the typical, Cat12 or Cat6, LTE channel. So what that translates into, obviously, is better coverage because you have, a higher loss threshold. And also, when you think about building a private network, you want to deploy fewer sites, lower costs. So that's where these narrow band or low power wide area type CPE equipment can really help in the deployment. Okay, next slide, Bobby. Okay, so Mark I like what Mark talked about gateways, and I kind of go along with exactly what he was saying. So when you talk about wireless gateways or routers for the private network, there's some things that you really should think about. And, Mark hit the nail on the head when he talked about multi-network dual SIM capability. You definitely want to make sure that whatever gateways you deploy, it's important that it can both support the public and the private spectrum for sure. And so, they could move in between carriers. It could be a Verizon or AT&T and then the private network. And the thing is that and some utilities are interested in even keeping that public network as a backup for certain applications. And then CBRS, Alan again talked about the CBRS channels, the 3.5 gigahertz. A lot of utilities want to maybe overlay for example, the Anterix spectrum with CBRS and more concentrated hotspots. So gateways, modules that can do that kind of thing could be pretty important. And then you can even take it to the next stage. For example, a gateway that has a dual radio design. So you could have one radio that's always on your public carrier, and one on the private carrier. So you really never lose connectivity, multi-radio. And, actually we're seeing applications now with direct transfer trip, where it's a dual radio design because they want to make sure that, get as close as possible to 5.9's architecture and having that backup radio always on without actually having to make a transfer can be pretty critical. Just a couple other things, obviously utilities need rugged. Depending on the application, they may need different interfaces. RS-232 for some of the older, Modbus and DNP3 type applications, maybe 485. Ethernet, for goose messaging, that sort of thing. And then, they may also want to use Wi-Fi for a vehicle area network. So with that, Bobby, you can take it to the next slide. I think one thing that you really, utility really can't skimp on is network management. It's important that the utility can do things with their devices, their CPE equipment, be able to do upgrades on devices. There's always security, there's always threats that are going on, different cybersecurity threats. So you want to be able to do security updates. You want to be able to pull performance reports, location information, coverage validation is important as well. So network management is just crucial. We all know that utility doesn't want to be rolling a truck for everything that any kind of issue that goes out in the field. And the other thing is you're deploying a private network. More than likely, you're going to also want to deploy a private on-prem device management system. Just kind of makes sense with what's going on. You deploy a private network, deploy a private device management system as well. One other slide, Bobby, and then I'll hand it to Kreg. So, as I mentioned on the previous slide, security is crucial, especially when we're talking about critical infrastructure that a utility has. There's a lot on this slide. I'm not going to get into it all based upon the time constraints we have here, but just some key points. Excuse me. Any equipment that's connected to the gateway or the CPE equipment, you want to make sure that that's authenticated or can be authenticated. The gateway itself should be secure. And what I mean by that is the capability to do secure boot. Any software that's pushed down to the device should be proven or tested, verified by digital signature. The data from the gateway that's going to be carried over the network should be, you can do or needs to be probably encrypted with either IPsec or TLS. And there should always be mutual authentication between any of the gateways that are out on the grid, and then the servers that are back in the distribution operations center. And really, like I said on the previous slide, I can't stress enough about the importance of network management and device management. Basically, to catalog any configurations that are out there, be able to monitor performance, and then also, be able to push the patches or any updates that are required. So, Bobby, I'll hand it back to you.
Thank you very much, Warren. That was really helpful to see it illustrated that way. Our final speaker is going to be Christoff from Motorola Solutions. Kreg is a vice president with Motorola for more than 25 years. He's got many years in SCADA, system architecture and design, and system integration, as you might guess. His responsibilities now include utility sales for North America and helping to prioritize the products and projects within Motorola solution stack. So, Kreg, to you, sir.
Thank you very much, Bobby. Thanks everybody for joining, and thanks the other speakers as well. So, I'm going to talk a little bit about the LMR to broadband convergence journey, is what we like to call it. I get this question a lot when I go visit my customers. Should we continue to invest in our LMR technology in the face of private LTE or just broadband in general, right? So the two paths up there to the LMR broadband journey, right? Broadband, it could be carrier, it could be private LTE, but really to answer that question, if you can go to the next slide, Bobby, what I want to do is talk a little bit about what are we really talking about here and what are we comparing. Broadband, some cool pictures here, very fast, but it's purpose-built, right? So the takeaway for this slide is really everybody's looking at broadband. Everybody likes private LTE. Why do we keep investing in our LMR? Do we need to keep investing in our LMR? The LMR story really is, it's mission critical built, right, for voice. It's purpose built for public safety, and it's purpose built for utilities with devices, handhelds, and a lot of things I'll talk about what differentiates that. So to answer your question, if we're comparing private LTE, carrier LTE to Project 25, even DMR, then the answer is yes, right? Keep investing in LMR, but with the vision of LTE down the road. And there's some things, if you go to the next slide, what I like to call the 6 C's, right? When we start to look at our customers that, have LMR today, we now have a broadband, or we've been in the LTE broadband business as well. So we have a broadband offering. So I want to take our customers and say, hey, let's get you into where you want to be. It's one of your TCOs and your calculator to get to broadband, to private LTE. We start looking at the 6 C's and we say, okay, what does it take? The big question is up there on the top, right? 20 or 20XX, right? When will it be able to be a switch, right? Where you can say, hey, you know what, LMR is decommissioned. I'm going to go to, let's say, mission critical push to talk over private LTE. So that's the challenge we're all faced with, right? And we're working on getting there, but there's some key things when you look at coverage. I think that's going to be one I'll spend a little more time on, is the large geographic footprints that most of our large investor-owned utilities. You're talking statewide systems. You're talking about, large geographic, right? And building out. I think Alan did a great job of talking about different spectrums and how they propagate. The sub 1 gig, we start looking at, okay, we can get that LMR coverage with some of those 900 megahertz. The Anterix spectrum coming out hopefully soon. Start looking at that. But when we design our LMR systems, we design at least, a minimum of 95% coverage. That's going to be a ways down the road when you're starting to build out your private LTE today. So those considerations, capacity, right? We're all looking at data capacity today, but we're putting voice PTT into our TCO calculators. When we design our LMR system, there's I'll say a boatload of capacity when the moments matter that you have to have when you have multiple agencies, and it goes to mutual aid, and the same thing falls back to the utility market as well. So capacity and coverage will take a play in there. Control, I think things are getting there. QPP, interoperability. Those are the kind of things. Can I talk to this agency? Can I talk to mutual aid from utility A to utility B? Those are the things that are slowly getting there. They're not there yet. Capabilities, are the right devices there, right? Can the devices toggle seamlessly, or is it leaving, a mission critical safety of the utility if the device roams out and he goes on to a carrier or he goes on to private LTE and he doesn't roam back and this radio stays in the same mode. I mean, there's a lot of different things that a purpose-built LMR system takes into place. Cybersecurity, I think both of those are marching down the right path. But the other big thing is cost, right? We mentioned earlier about different spectrums. What's the cost there? The cost to put up sites, the cost to put potentially EPCs at the edge to get some of the feature functionality that you have in LMR that you don't currently have in private LTE or carrier LTE. And a couple of those just identified in that one box there is private LTE, some of the challenges. Local site failover, right? So if a site goes down, the radios or the UEs that are associated to that site are basically down. And that's the same with the LTE or the EPC, right? So if the EPC goes down, same thing, your system's basically down. With LMR, it does have what we call a fail-soft, where you still can talk unit to unit, one-to-one, or that site has what we call local control, and that site becomes a controller as well, and you can do local control at that LMR site. Some of the other ones, when I mentioned one-to-one talk, the devices, the UE devices for LTE are typically 250 milliwatts from a voice device. That's going to be a limitation, how far you can talk peer-to-peer. The other limitation would be multicast currently today. There's a limitation of one-to-many. We can talk more about that, but the big one is coverage. We do have a couple tools that you may be familiar with to bridge some of the interoperability and the application sharing between LTE or broadband and LMR. Critical Connect and the mission critical push to talk Kodiak is the engine that a lot of the carriers and FirstNet are using as well. So Bobby, if you go to the next slide. When I talked about coverage, I just ran kind of a simple high-level view of what coverage would look like for Illinois. So Motorola, we have what we call our statewide systems. I think we've got close to 38 different statewide systems, but the one that I'm displaying here, we're leveraging our recently announced high-power eNode B. It'll go up to, I think for this exercise, we went up to 160 watts per sector, so 80 watt 2x2 MIMO. And you can see for 250 sites, we have 95% coverage of the state. And that's using, from an uplink, we have a 2 watt high power UE that we're also introducing as well to allow the utilities to have coverage on the footprint without having a ton of sites out there, and leveraging from a cost point of view our existing LMR sites that are already out there. So I won't spend too much time on that, but if you go to the next slide. This is just a general overview recap slide. The wide area networks, right? When I talk about convergence, right? Everybody wants one. I think, you know, each one of the speakers pointed out there'll probably be aggregation or carrier, you know, leveraging the carrier, leveraging private. There might be leveraging AMI and leveraging LMR as well down the road for future use. But really, the takeaway from this slide is, I think Mark pointed out as well, is intelligence at the edge. You think about some of the things, how do you minimize the amount of data that you're doing today? Do we really need to have our SCADA pull? Things are becoming smarter at the edge. We're making investments in not only edge devices, edge gateways that are capable of doing local control of devices, but have programmable logic built into them. You may recently, I think AI is becoming something that will really be a game changer in our industry, right? So we look at artificial intelligence at the edge. We purchased a large video company, Visualon, last year. The analytics in that are just amazing of what you can do to detect things where you don't constantly have to send data back and forth. So really what I want to show on this is the devices, the convergence of, you know, leveraging the different wide area networks, and just making smart decisions at the edge. So with that, Bobby, I'm going to turn it back to you.
Great. Thank you so much, Kreg, and thank you to all of our speakers. That really built on the story that we at UBBA talk about on a weekly basis. If you have questions, remember to put them in the question tool. We did get a good question in, something any of you guys on the phone can answer. We talked a little bit, Kreg, you were just getting ready to go here, I think, but what types of new IoT applications do you think are going to benefit utilities in some of the scenarios we're seeing? Any one of you can answer that.
Yeah, this is Kreg. I think
applications. Oh, sorry. Go ahead, Kreg.
I mean, there's all kinds of new things popping up. I mean, fault detection is probably one of the biggest ones right now, just a smaller. But I mentioned video in the substations, not just from a security point of view, but from an application point of view, being able to detect different, you know, scenarios in the grid and then making smart decisions with that analytics without tying up bandwidth, right? We all know, as Alan pointed out, bandwidth is the most scarce commodity that we have right now. So I think that's one of the things video will start, and AI will start to become more prevalent in the substations and the distribution as well.
Thanks, Kreg. Warren, did you want to add?
Yeah, I just, you know, we're seeing IoT really, you know, take root beyond just the traditional bulk energy delivery. You know, things like monitoring, believe it or not, monitoring poles, you know, and lean and tilt. You know, if we can get to the sensor side there. The fire mitigation is another big one. You know, Kreg touched on it with some video. You know, monitoring weather, you know, a lot of it's IoT, again, focused, and then being able to isolate, you know, those sections of the distribution grid if there's a, you know, high fire risk. So, and even vaults, monitoring water, and, you know, being able to be proactive in pumping them out. Again, it's not, you know, this is all IoT stuff that's really not touching capacitor banks, you know, reclosers, sectionalizers, and that sort of stuff. Pretty interesting.
Excellent. Thank you. Mark or Alan, anything to add on just that question before I go to the next one?
Yeah, maybe just like asset tracking would be another application. I mean, you know, knowing where, you know, even pieces of equipment are, right? Backhoes and things like that.
Interesting, yeah. And that is something we don't think about sometimes when we try to think about grid edge or computing or IoT. You know, we try to think of those whiz bang kind of things at the end, but those basic utility needs are still going to need the right bandwidth and the right communications infrastructure in order to drive that forward from an operational perspective. So I appreciate that. Are we seeing I think we have time for one more question. You know, at UBBA, we work a lot with, we've got a whole group dedicated to use cases, and we talk about some of these different things. So if anyone wants to make comment about from utility use case needs, requirements, and when you're looking at the technology for all of those things, the bandwidth, the spectrum availability. Any final comments on utility use cases that really need to consider what we're talking about from a private broadband network?
Yeah, absolutely, they do. I mean, so, you know, from a Southern perspective, I mean, what we've done and continue to do is take all the use cases, the bandwidth requirements for those use cases, and model all that with our network, and you know, and you find out, you know, where you think you'll have utilization issues or not, and then you know, kind of design your network around that. So yeah, I mean, absolutely, it all factors in. You know, the nice part is many of the applications and use cases for utilities today, at least, aren't real heavy bandwidth hogs. So I mean, I think you know, we have a 3 megahertz LTE channel, and we support, you know, quite a few use cases, and you know, an ever growing number of devices on those. So you can do a lot with an LTE network.
You know, Bobby, I think it's worth remembering that in a private LTE deployment, you have the advantage of being able to prioritize all of those use cases relative to each other and relative to everything else that's on the network to get the proper performance that you need.
That is an excellent point, Mark, and Alan, a great way to close this off. So I think that's a good stopping point. But what I do want to say is let's continue this conversation. The Utility Broadband Alliance is going to have a workshop at Distributech. You see the information there on your screen with the room location. You can register for that event by clicking, going to that web address there at the bottom if you haven't registered already. We would love to welcome you there and continue this conversation. If you're not a member of UBBA, particularly utilities who need help with this discussion, please reach out. We have a lot of utilities and we have a lot of solution providers who are ready, willing, and able to help you with the challenges that you're facing about private broadband networks and about keeping your infrastructure not just up to date, but for the future. So I want to thank you again for joining us today on this webinar. Thanks to our speakers who went through all the trouble to share their knowledge with us today. Thank you to everyone who was on the call and asked great questions. If I didn't get to your question, I'll reach out to you by email and follow up on that. Of course, if you have any questions, please don't hesitate to call or email me. And I hope you have a great rest of your day. Thank you all very much.
Thank you.
Thank you.